Today we're going to be talking about building a COVID-19 project recommendation system using MLflow and a couple of other tools from end to end. So everything from coming up with the idea to build this project all the way to actually implementing it and having a system that somebody else can use and interact with. This is a project that I think is also fits really nicely with the hackathon for social good, because if you actually use this project, you might be able to find some other existing projects in the open source world that somebody else has done to contribute to COVID-19 research or insights or anything like that. To get started, I want to give a quick intro to myself. This is not my apartment. If you can't tell, I'm in a YouTube channel's test kitchen right now because I thought it'd kind of be like a cooking show, but we're cooking up models instead of food. Just to give an intro into who I am, I am the co-founder and CEO of Booklet.ai, which I'll talk a little bit more about in a minute. It's a tool for data scientists. Before a Booklet, I was at a company called Brandless, an e-commerce website where I led the data team. We were excited to be an early alpha user of MLflow a few years ago, which is kind of how I got involved with MLflow. And before that, I was at Uber. I was also a data scientist there and worked on a variety of different machine learning models and such. So that's a bit about myself. Just to kind of go through today's talk, I want to give an overview of what we're going to cover. The first piece is just the problem space. So what are we trying to solve for? What is the actual goal of this project? From there, we're actually going to talk about the recommenders a bit. It's important to note that this talk is mostly focused on the full system. We don't have a ton of time to dig into the specifics of the code or the algorithm, but I will go through and talk about a little bit of details around that just to give some context. From there, we'll actually go through about how it works just at a high level, and then go through the demo of actually running the code alongside going through those steps. We should have 10, 15 minutes plus, hopefully, for Q&A at the end. I'll also give some channels to follow up with specific code questions later on, just in case we don't have time or if somebody has specific questions later on. But to go through the problem space first, I think a month or two ago, I was trying to figure out how I can help out with all the different awesome research and work that the open source community is doing to help the COVID-19 pandemic around the world. And I was quickly overwhelmed by, and it's awesome how many people have actually contributed to the work that's going on in the open source community with the goal of fighting and hopefully reducing the spread of COVID-19. But you can quickly see that if you search for a couple different terms that people use to reference this, there's over 53,000 repositories right now that are being contributed to. Millions of lines of code, tons of commits, tons of different people that are contributing to this, and it can quickly become overwhelming to find a project that really kind of fits with what you're hoping to contribute to or what you're hoping to use or learn from. So that's the whole goal of this project, is to help people better find projects they can contribute to. Before we talk about how we're actually going to go about doing this, I want to take a minute to talk about recommendation systems. So recommendation systems are, they're pretty famous from whether it's you're on Netflix, what should you watch next? You might be on Amazon. There might be, hey, what can I buy, or any other e-commerce site, and recommending things you might want to buy. But there's really kind of two different types of recommendation systems. There's a collaborative filter and there's a content-based filtering. There's a lot more combinations or other types of systems, but at the highest level, there's really two different types. The collaborative filter is all about taking what other people have done and helping a new person figure out other similarities and watching that. I kind of think of it as a voting system. If you watched video A, somebody else watched video A and video B, it's likely that you're going to want to watch video B as well. In this case, we don't really have information about what all these people have worked on together, all these different projects that they've worked on. We also don't necessarily know if people are working on multiple projects. So instead, what we're going to be focusing on is a content-based filtering system. So what this does is it basically says, okay, what is an example of something that the user is interested in? And then finding similar things to that, let's say it's a show in this case, or a repository in our case, finding similar actual examples that are similar to what that user is actually looking at. So in this case, we're not actually looking at other users' actions. We're instead comparing similar, this is called articles, but in our case, it's going to be repositories. Going off of that, how this actual algorithm works, in our case, what we want to do is we have a user that is interested. What they're going to do is they're going to input some information about what they're interested in. In this case, this might be details around, the country that they're trying to contribute to, the language, maybe what topic they're hoping to use. And then what it does is it actually finds similar repositories that are similar to those inputted by the user, and then recommend those repositories back to that user. In this case, a simple example of this is that what if the user inputs, Sweden, Python, dashboard. These are 3 interests of the user based on their skill set and what they're hoping to accomplish. You can see that, if we looked at 2 different types of repositories, it might be that there is a dashboard showing COVID cases in Sweden using Python, or there's an API for COVID-related medical research papers using JavaScript. In this very intuitive example, we can see that Sweden Python dashboard is most similar to the top one because it actually has the word Sweden, it has the words Python, it has the dashboard as well. Unlike this API for COVID-related medical research papers is in JavaScript, it's very not similar to what the user is hoping to actually accomplish here. And then to actually show how this is actually going to work, we'll get to the actual view, but to see the system in action before, so you can kind of see how this is actually going to flow. You can see that in our case, somebody might want to put in Python and R because they're a data scientist. They might want to work with data. Maybe we want to use a dashboard and an analysis. And in this case, when we actually say what are the similar repositories, we can see that there's a list of repositories that are most similar to what we're hoping to use. A data analysis, a daily analysis, different data sets, and we can see that this is in Python or R and all these different systems. So if we wanted to instead do something like JavaScript, and we instead wanted to use an API, we're probably going to get a different set. So here's an API built in JavaScript, or a mobility report built in JavaScript. So you can see how those examples are kind of happening in real time. So this is what we want to build. How do we actually go about building this? Using the skills of a data scientist and the tools that exist, and it should be free to use. So what I want to do next is talk about how this actually system works. This is going to span a couple of different tools, a couple of different projects. So instead of going through this whole overview, which I'll reference back in a minute, I want to go through it step by step. So in this case, the first thing we're going to be doing is training the model. We're going to take data from GitHub. GitHub actually has a nice repository data set that we can use. We're actually going to train the model using Databricks. And this will be going kind of fast. I'll go through this actual flow in the demo. From there, we actually want to take that model that we built and send it to MLflow, which is also hosted on Databricks, for versioning. So in this case, we can try a couple different models out and then see which ones we actually want to end up using for our production system. In the process, we need to build up a Docker container, which I'll talk about. And then we're going to send this model to Amazon Sagemaker, which is a model deployment framework on AWS for deployment. So we'll send that model that we have, that we feel good about, and we versioned and send it to AWS. We'll also be sending that Docker container to hold that model. And then finally, we're going to be using Booklet, which is the company that I'm a part of, and I'm helped found, that's going to actually build a web app. And we're going to deploy that model that is on SageMaker into a web app so that somebody can take advantage of that nice input and structure that we had before. Because if a model is just sitting in SageMaker, it's going to be an API, and it's going to be tough for somebody to necessarily use and actually get value out of. And by the way, if anybody has any questions, feel free to pop them in the Q&A. We'll try to answer them at the end in this section. But if there's anything that pops up that's like kind of urgent or we need to take a break on, I can stop in the middle. Cool. So let's talk about the demo. Most of this is going to be going through the demo. There is going to be a lot of code that we go through. I don't really like just pulling code up on the screen, but in this case, we don't have time to necessarily go through all the different pieces. But before we get started, there's a couple of requirements for this. We're running this in a Databricks account. So you can set up a Databricks account with a free trial, and we're running it on top of AWS, which you can also set up with free credits. So you should be able to kind of get this going pretty easily. We're also going to be using a Booklet account, which is free as well. If you have any issues getting any set up, feel free to reach out afterwards or anything like that. And then just for some details around what we'll be going through, We have the code, the actual blog post that I've kind of written alongside this, and then the demo, like the video and everything will be shared afterwards. So that if there's anything that we move too fast on or you want to go reference again, we can go check it out. And then, like I said before, a little bit too fast for code details, but feel free to place issues in the GitHub repository afterwards if there's like specific pieces you want to call out, or if you want to fork it and send me a PR for changing things. I'm really open to kind of collaborating on this project. I'd love to see it expand. Great, so let's go ahead and get started with the demo. Like we talked about, we want to build this basically system. To do that, we're going to start here in Databricks. And to start and kind of follow along where we are in these different steps in the process, right now we're in the model training phase. So to get started, we actually need to find the data set. First we'll import a bunch of libraries in Python. Go ahead and get that kicked off. And one thing to call out is that one of the functions that we're using is MLtk, which is a text processing library. And when you're in the process of doing that, you actually need to download some different pieces outside of the typical import statement. So in this case, we're downloading these two packages of text transformers. So we'll talk about once we use them. But to actually talk about the data set that we're actually pulling from, there's a data set that GitHub has open sourced, which is in this case. And you can see that this is a data set of COVID-19 repository data. In this case, we can see that there is a data set that is available in both tab separator values and JSON form. And what they essentially are data sets that contain all of the different repositories that are related to COVID-19 research. GitHub has created an algorithm that can find all of the different COVID-19 related projects. You can see that nicely formed data set for us, which has the repository description, it has the repository owner name, and a variety of different things about it. Does it have a README? Does it have a Wikipedia? Does it have a wiki, not a Wikipedia? Does it have issues and all these different topics? And this is a helpful data set for us to build off of. When we actually want to go build this, we can see that our library import's completed here. We can go through now and we can actually go import this data set. And to talk through what we're doing here, all we're doing is we're pulling, using the URL lib package, we can just pull this data set in directly into our Databricks file storage system. And then we can now read this into Pandas, which we'll be using for most of this. So now if we want to actually go in and check out this data set, we can just test it out here. So we can see that now, that very similar data set to what we had inside of GitHub. We can see that we have all the different topics and information that we need here. So what's next? As with all data science projects, I'm just gonna go ahead and remove this cell. As with all data science projects, we have a lot of data cleaning to do. As much as it would be nice to be able to just plug in this data set into an algorithm and make everything work magically, it's not actually going to be set up that way. So we're going to go through a couple different filtering steps and a variety of different pieces, which I'll talk through at a high level. So what we first want to do is make sure that out of that 50,000 repositories that we talked about, we want to make sure that all of these data sets are actually something that we feel like is looking for a contribution, right? So in our case, if somebody is just doing a small project on the side, maybe they're not looking for somebody else to actively contribute to it. But when we're building a recommender to make sure that people can go find these new projects, we want to make sure that these projects can be contributed to and used by other folks. So we're going to do a couple different filters in this case. We're going to have, make sure that there's a merged PR and get it up to make sure that there's collaboration. It should have a README so you can kind of understand what's going on. It should also not be missing a repository description, a primary language name, and then we want to make sure that there's at least 2 contributors. In this case, this is all just making sure as a proxy to make sure that we actually have the correct, indicator that it's likely to be contributed to. So we run this really fast. Now what we're going to do is set up a couple different functions to help us clean that data set. In this case, we want to detect the language and also handle errors in this case, because sometimes it's going to break. In our case, we want to check for Latin letters just to make sure that our algorithms are going to work correctly. We also want to remove punctuation. So these are a couple different functions that we've gone ahead and defined. And then there's a big block of processing here. And I don't want to go through this in detail. This is something that I think would make sense to review afterwards, but I'll go ahead and run it because it takes a minute. But at a high level, what we do is we go ahead and check the language. We limit it to English. The first pass of this, just to make sure it's easy to debug on my end and everything, we have limited it to English. If somebody wants to contribute and expand it to a new language, I would love to kind of collaborate on that. But also I'm limiting repos to Latin characters to make sure it's easy for our NLTK algorithm to feed through. And then it's surprising how many emojis show up inside of GitHub repository language in different mentions. So what we do is actually convert emojis to text, which is kind of a fun package as well. You can see that there is a emoji.demojize. I don't really know how to say that, but it's a nice helpful thing. So once we actually go through and run these steps, what we need to do is we need to take all of that and clean it up and turn all these descriptions, the topic, and the language into a big bag of words. And what that essentially is all of our words that we want to think about with the repository and turn them all into one string of words. What that allows us to do is it's a pretty common natural language processing technique to say, instead of having a bunch of different features, you want to have all of your different words all in one string so that we can then reference them later. Great, so it looks like this ran. We got a couple warnings, but we'll skip over those for now. And next thing we want to do is actually run a tokenizer. So tokenizer is taking that set of words and making it so that we can actually go and figure out, okay, does Sweden match up to Sweden here? Does Python match up to Python? And we're actually going to turn this into a large vector of different objects here. So in our case, what we want to do is first create a lemma tokenizer. And what this does is it basically matches words to their root. So if you want to say, cases versus case, or those different topics there, an algorithm shouldn't really understand the difference between those two. And in reality, they should be the same, right? Because it's either a plural or a past tense of the similar words. So we'll go ahead and kick this off, just pulling this in. And next thing we want to do is actually pull out stop words. So, and stop words are words that allow you to basically, it's a fancy way of saying remove them from the analysis. There's a lot of words like the, all those different words that aren't really helpful for us to do an analysis. We want to go ahead and remove those. But usually for a project, you also want to add on additional words that are most related to the project you're actually working on. In our case, we want to include a bunch of words that are actually describing the COVID pandemic, because all of the different repositories have that information. So we want to go ahead and remove those because we don't think that's important for us to actually do the analysis. And the reason for that is if somebody types in COVID here, most of these are going to have COVID related words. So it's going to end up adding noise and more words to the process that we actually don't want to reference. So in our case now, once we've actually set up the lemma and set up the stop words, we're going to build out a count vectorizer, which allows us to create take those words and turn them into a big vector that allows us to understand what's inside of those sentences. In this case, we want to have just a single word at a time. We're going to pull out those stop words, and we're going to use the lemma as well. And when we set up this vectorizer, next thing we want to do is actually fit and transform this vectorizer, this string of descriptions that we created earlier. So if we actually want to go check out what this looks like, up here, let's just go ahead and add a cell below. Let's just check out what this actually looks like. We can see that now we have all of these words that are listed out here as one big bag of words. The emojis are still showing up here, but I think it's just because how it's rendered here. And what we do now is actually take this and turn it into a very large, confusing matrix. So if you want to check this out now, this is now a very large matrix, and we can actually go and print this out as well. And we can see that now, this is now a sparse matrix that's representing where all of these different vector references are set up inside of this large matrix. So each individual repo here that we can see, COVID-19 data and dashboards for South Africa, is now represented as a large matrix to show us which words are actually listed out in that piece. It's important for us to note that we're both fitting and transforming in this case. So we'll reference this a little bit later when we go through the process of actually using this to run the model. But once we've actually built out this sparse matrix, we're going to go now and build the prediction function. So what this allows us to do is take in input from different users and then say, okay, which repositories are most similar to that input when we're doing this matching here. So what we're going to do is we're going to take this input data frame here. We're then going to turn that into a bag of words. So when somebody actually goes through and gives us JavaScript and TypeScript and Vue, and then maybe a couple different strings, we're actually going to pull all of these into a single string of text, and then turn that into a bag of words. What we do now is this word vectorizer that we referenced before is going to be taken from above, which we already fit before, and then we're just going to use it to transform that data set that we brought in earlier. And then I don't want to go through a lot of detail here, just because we probably don't have the time to go into in depth. But what we have is we want to figure out which ones are most similar based on the input vector and all of the repositories that we have in our list. And then we can go through, once we come up with a similarity, we can go through and find the top 10 most similar repositories to what we actually inputted, and then return those repositories as the recommendations. So all of this, if you have a chance to kind of run this, check this out. Let me know if you have any questions as you're kind of testing out the code. And then from there, this is where MLflow kind of comes in. So I want to take a minute to show where we are in the flow. So we went ahead and took the GitHub data set that we ran before, and then we've actually built the model. What we need to do is we actually need to send this model and prep it for versioning inside of MLflow. So MLflow has a nice function for a Python model. What you can do is you can send any arbitrary Python function, which in our case is this text recommender, and send it to MLflow as a wrapped up model. And what we need to do here is we need to send all of the different data sets that we need, which is the vectorizer, the matrix that we had, a repo lookup to pull out the actual repository, and then the function itself, and put it all into the output for the prediction function. So now we have this one class, which is a COVID-19 repository recommender that allows us to take in input and return the list of repositories that are most helpful. So we can actually test this out now, just to kind of give a sense of what this actually looks like. We're running this class that we had up here. We're feeding in these different objects that we used before. And then we're going to actually run it on something such as, Python and data in this case. So once we run this, we can see that now when we ran Python and data, it's now returning in a non-easy to understand output that we have, the first repository that we're looking at is a data analysis of the COVID-19 outbreak. The next one, and this adds much different information about it. The next one is a data source fetcher written in Python, right? So this really makes sense from a Python and data perspective. And the reason this is working is because it's finding the vector of the inputted structure, it's matching it up to all of the other potential vectors that exist, and it's finding the most similar and sorting them and outputting them. So this is great, but this isn't really useful sitting inside of an IPython notebook because very few people are going to be able to go run this. What we want to do instead is actually log this model to MLflow so that we can start prepping it for deployment. So now we're on to this next stage, which is actually managing and prepping the model. So this is where MLflow comes in. You can spin up MLflow locally. What's nice is that Databricks actually has a version of MLflow that's hosted inside of the system. So here you can see that MLflow is set up. I've run some models in the past that are actually stored here, and you can see details around those models and some parameters that we're storing. So let's push a new one to it. So keep in mind now that we have a couple different models sitting here, run by my email address here, which is support@booklet.ai. And first, what we need to do, I'm not going to dig into this too much, is set up a Khan environment, because that allows this model to know how to run when we push it up to a variety of different systems. So we'll go ahead and kick that off. The next thing we want to do is start a run in MLflow. We want to name it the COVID repo recommender. And then we want to go ahead and log the parameter that says, hey, we're only going to return 10 repositories in this case. And we're going to use the function that says log model and we're going to go ahead and log that entire object that we had tested before right up here. You'll see that this looks the exact same right here. Is what we're running down here. The COVID-19 repo recommender class, and we're pulling that through. We're also going to send the content environment. And then when you go ahead and log this, you're going to see that it's now, let me take a second, and what it did was it now sent an extra model to the MLflow instance. So now this latest one that we just ran is now sitting here. We can see that this is here. We can also see that all of those pieces of the model that are actually available. We can see that the configurations that we have set up, the content environment that we sent, and also all of the model objects are all available here. An important thing also to note in Databricks is that you can actually see these runs on the side as well. It's nice to have these right here on the side. Once we're actually done setting up that model, we want to go ahead and make it available on Sagemaker for other people to use as an API endpoint. So the way this works is actually, first you need to make sure that your Sagemaker instance on AWS has a copy of the Docker container that can run the model. I'm not going to do that on this live demo, but all you need to do is run MLflow Sagemaker build and push container. And this has all the functions built in to allow that Docker container to just be pushed up into AWS. And now what we want to do is actually go ahead and deploy it. So in this case, to talk through this a little bit, we're referencing the model that we ran before using this. We have the experiment ID and the run ID from MLflow. And then what we want to do is we actually want to put in our account ID, we want to put in our region, and then we're going to set up a couple of permission systems. And in our case, we want to set up the endpoint name. So we want to go ahead and send this endpoint into AWS SageMaker so the model is available. And to show what that looks like first, you can see that we have a bunch of SageMaker models sitting in our instance here. And these are all different models that we deployed using MLflow or other systems. And what we want to do now is actually go ahead and run this. What this does is it takes that model that we have set up in MLflow. Oh, I didn't name it the right thing. So it has to have a certain specific structure for naming. So let's go ahead and just call this live too. What this is going to do now is it's going to take this endpoint that we have set up. It's going to take this model that we have set up in MLflow. It's going to go ahead and send it into SageMaker. We can see now that if we go ahead and refresh this, we should see that this model that we have just deployed is now in the creating mode. Eventually, it'll look like these other models that we have set up here, which is essentially an API endpoint that anybody can now go access. And that is set up by running this code inside of using the MLflow functions to then deploy it actually to SageMaker, which is this step right here. Now that we've deployed the model, this is actually going to take like 10 or 15 minutes to get it all set up. I'm just going to go ahead and act like we've already deployed it using something like this existing one that we have here, the COVID-19 repo recommender. That is now set up. And what we want to do instead now is go ahead and make this model useful to the end user. So this in and of itself is an API endpoint that a very technical user could go and talk to. But instead what we want to do is make it so it's easy to turn into a UI. So that is where Booklet comes in, which is a system that allows you to build a web app pretty easily based off of an existing API endpoint that has been set up through a different system. So let's go over to Booklet now. And you can see this is the home page for Booklet after you create an account. It's free to set up. And when you're actually here, you won't have any models here when you get started. But what you actually need to do is just make sure that you have the proper SageMaker integration set up and all the docs are linked here. We are going to support other systems outside of SageMaker in the future, but SageMaker is what we're supporting now. And then if you actually go to a new model, you can see that there's a couple different items that you can pick here. One confusing piece is that this is an MLflow model, but we actually deployed it on SageMaker. So we're going to go ahead and click SageMaker. And then you can see that these other SageMaker endpoints that we have set up are all available for access listed out here automatically. So any of these different systems that you've tested, these endpoints that you've set up, you can access here. So we're not going to go through the process of actually setting it up live. Instead, what I'll do is show how we can actually build this system, the system that we talked about before. So let's go back here, the COVID-19 open source project recommender, and let's go into edit. And you can see that we actually selected that example of the model that we have deployed through MLflow onto SageMaker. We give it a nice name so that anybody can kind of understand what it looks like, what it is. We can give it a URL just to make sure that it's easy to understand. And you can also add some descriptions so that people have the context of what your actual model is building. And that is what is filling in these different pieces. So here's an image, here's the title that we put in, and here's the actual description that we have set up here. Next thing we want to do is actually build out this structure so that anybody can go in and select the different languages they want to be able to use. So to do that, what we want to do is actually set up the feature schema. So what the feature schema does, and I actually have this pulled up in Sublime just to make it a little bit easier to understand. What the feature schema does is it basically allows you to set up, okay, what are the different inputs? What do I want those options to be in this case? So you can see here that if you go into the demo, the options are listed out here: JavaScript, Python, HTML, Jupyter. And that is configured based off of, here's the programming language, you can select one or many, and then here's all the different options. And we're saying that multiple can be selected in this case. That's why we're able to select multiple here. We also want to have the keywords in this case. So we're going to have, you can select, anything across data, the app, the project, anything that you want to reference there. And this is also a multi-select in this case. What this allows you to do is, instead of making somebody configure like a JSON structure to send to an API endpoint, instead you can just set up your input here. So the next thing we want to do is set up the post-processing. So in this case, this looks a little bit confusing, and I'll talk through it in a second. But what we want to be able to do now is actually, let's just get rid of this and update it. And what happens now is when you first open up the post-processing for Booklet, what it does is it takes all the default feature schema that you inputted and takes and says, okay, what does the output of that actual model object look like? In this case, we can see that same structure that we had inside of Databricks here, which is this very large structure of all these different pieces. This is helpful if you're a data scientist. You're probably like, oh, that's a pandas data frame converted to a JSON object. But in our case, that's not really helpful to somebody else. So instead, what we want to do is actually make this easy to understand and use, and build this out. And I'm definitely not a JavaScript engineer. I'm a data scientist, but with the help of a friend that's a JavaScript engineer, or just after some poking around, you can take this existing structure and actually put it into a form that's really easy to use and understand. In this case, we want to make it look just like a GitHub repository list. So somebody feels like they're on GitHub, or that they can easily understand that they're going to be linked to GitHub in this case. And just to call out what this is doing, you can see that we build all this structure at the top to make sure that everything is set up here. Like we could say, instead of, maybe we don't want the most relevant repositories, maybe we want to say top relevant repositories, and it's updating here live. What it also does is it takes these different pieces, such as the primary language, the count of stars, the license name, and actually inputs it into these different pieces here so that your model is really easy for somebody to understand and use. So now, if we go back to the demo, we can see that with the feature schema that we set up, we easily have a couple different languages that we can plug in. And then now the post-processing is not saved yet, so it's still showing up as large setup. So instead, if we go back in and paste in the post-processing, and then we go ahead and update the model, it's going to save that. And now the demo is much easier to understand and use. And just one other note on Booklet, one of the things you probably want to do is be able to share this model with other people. So we have this option to basically say, hey, make this public so that anybody can go access this model. And we've gone ahead and set up, COVID-19 project recommender, and that is where we reference this here. You can see that we've gone ahead and said app.booklet.ai model COVID-19 project recommender. So kind of in summary here, to go back to the overall view here, we went through the process of training the model in Databricks. We went ahead and used MLflow inside of Databricks to manage the model and set up the different artifacts and also information about the parameters that we want to have stored with the model. From there, we went ahead and deployed that model on SageMaker. You can see the other one is still creating because it takes a little bit of time. And then finally, we took that model that we had deployed on site with SageMaker, and then we went ahead and configured it inside of Booklet.ai. And all of these systems are really optimized to make sure that, really as a data scientist, this is where we work. We work in Python. We know how to make these systems work. We're not production grade engineers. We want to be able to take this code, send it to a deployment framework, and then easily make a web app out of it as it's set up. So that's kind of the overview there. I would say feel free to check this out. You can check out, we'll send these links over afterwards. Here's the demo that has actually been set up. Also, if you actually have specific questions about the code or anything like that, here's the repo. It's just under the Booklet.ai GitHub repository. It actually has the notebook here available. If you want to fork it and use it or build off of it, I'm open to it. Like, I'd love to have a collaborator. Feel free to like submit a PR. We could work on it. Or if you have specific questions about the code, feel free to drop an issue in here, and we can kind of talk about that so others can see it as well. Great. So that's kind of the whole process there. If there's anything else, so I'll go ahead and stop sharing now. I'll keep the share going, and see if anybody has any questions. If anybody has anything else they want to ask or dig into. Cool. So I see a couple of questions that have kind of showed up in the QA. Karen, let me know if I'm doing this incorrectly. Hopefully I do it correct. But the first one was just, am I able to use Microsoft Azure instead of AWS? So you should be able to, yes. So just to kind of show how that would work. Basically, when we're at this phase of deploying the model, you can see that we are taking Databricks, we're taking MLflow, and one of the nice things about MLflow is it allows you to deploy to multiple different frameworks. And I'll actually just like, so that everybody can kind of see it, I'll actually just pull up the MLflow docs. So in this case, we can see that if you go into the documentation and you actually go to models, you can see that there's deployment tools, right? And in this case, you can see that there is a couple local things that you can do, but there's also deploying a Python function to Azure ML. In this case, in the same way that we've done it with SageMaker, you can also do it on Azure ML. So I don't have the example code set up. If somebody ends up doing it, I'd love to put it in the repo as well so that other people can use it. But then once you actually have the Azure ML model set up here in a very similar way to SageMaker, you can go ahead and deploy it to Booklet.ai in a similar way. Because it allows you to, you can set up an Azure ML model as well. This is currently in beta, so if you end up testing it out, just let us know. Great. A question about just like the GitHub code details. Yep. So for the actual code, you can see that all of this is listed out here in the repo. It's just a IPython notebook here. And then to actually talk about the data set that we're actually using inside of GitHub, that's also available here on GitHub. And that's kind of linked inside of the notebook. So it's a helpful data set that's also available there. Cool. Another question about Azure. Just like I mentioned before, should be available. I'd love to kind of partner with somebody if somebody tests it out. I haven't done too much testing myself, but MLflow allows for really easily, pushing to a bunch of different places. Cool. And then another question was about how long did this take? Right. And obviously this isn't just like an hour-long project that is set up. What I'd say is the very first time you build out this flow, it takes a little bit of time to get used to the different steps in the process. You set up Databricks, you set up MLflow, you set up SageMaker. That's going to take a little bit of time to understand how the pieces fit together. But the nice thing is that once you have the flow set up, you can easily go in and set up different models along the way because the flow ends up being very similar. Maybe you're going to train a different model on Databricks, and maybe you're going to do a different deployment on MLflow. Finally, you'll deploy it to SageMaker and put it on Booklet. And just to kind of give an example of that, if you go into the repository, you can see that I also have a lead scoring demo here that is a very similar flow. And it's also available as the lead scoring demo here as well. So what I'd say is like the first time you get this set up, give yourself quite a few hours to get everything hooked up and ready to go. But then ultimately what you want to do is spend most of your time focused on building out the actual code that runs the model. Everything else is kind of fit into place. And then the model, if you want to go super deep on it, you could spend, many weeks on a model, years on a model, or you can do a model pretty quickly within a couple of days. But yeah, like I said, if anybody's getting ramped up and testing it out, definitely reach out. I'm happy to kind of chat about it further. Once you get a good flow of building all these different systems together, it's really fun and exciting to be able to just come up with a new model structure. a model idea and be able to deploy it all the way end to end. At the moment, I'm actually working on a recipe recommender right now. Cool. So the Azure connection in the chat. Yeah, so I can actually send, I'll go ahead while we're here. I think I can share a couple of links just so that everybody has this available. So if you actually want to go into MLflow docs, here is the Azure section, just because this is something that a couple of people have asked about. So there's the Azure link in the MLflow docs. If you want to go ahead and try out the repository data, here is the GitHub link for the repository data. And then also if you want to test out the lead scoring, sorry, no. Let's actually go to the recommender. This is actually the code that we actually ran today. And then finally, if you actually want to test out the project, if you actually want to go and test out and see how this works, here is the link to the actual demo as well. If you test it out and you see a weird result, definitely let me know. Like, I'd love to understand the issues just so we can fix it. Some of the best ways to actually debug a machine learning model is having a lot of people test it. A machine learning model can't necessarily work 100% of the time. It's not, it's all about predicting. Great. So I think that covers all the questions. I don't know if there's anything else that popped up. Like I said, if anything pops up, feel free to pop it into a GitHub issue and let me know. And I'm always happy to chat. But thanks so much for attending and for all the questions.